In this first problem, you're looking at the more tickets I sell, the more money I have, and you have to identify the independent and the dependent variable. So when thinking about the independent and dependent variable, you have to figure out which one of those statements depends on the others. So if I look at it, does the more tickets I sell depend on the more money I have? No, that doesn't make any sense. So the more money I have is our dependent variable. Dependent is the money. And then the independent variable is the amount of tickets I have. Because if you look at it this way, the amount of money depends on how many tickets I sell. And that makes sense. Judah brings reusable shopping bags from home whenever he goes to the grocery store. The number of bags he brings is based on how many products are on his shopping list. So our two unknowns are the number of items. So I'm going to put right here, number of items is an unknown, just like we did in class, the number of items. Okay, and then you have the shopping bags are the second unknown. So now you would say to yourself, which one depends on the other? So does the number of items I buy depend on the shopping bags? Or does the number of shopping bags depend on how many items I buy? So to make sense of this, the number of shopping bags that you need to have depends upon the number of items you have. So this is your independent variable and this is your dependent variable. At a deli counter, the price of a customer's order is based on its weight. So you have two unknowns here. You have your dollar amount, and then you have your weight. So I'll call it W for weight. So we have to decide which one is the independent, which one is the dependent variable. So does the weight depend on the price, or does the price depend on the weight? And if you think about it that way, the price becomes your dependent variable and the weight is your independent variable. Vera and Elizabeth are going hiking and are trying to figure out how many snacks they should bring on with them on the hike. The longer they plan to hike, the more snacks they should bring. So we have two variables here. We have the amount of time, right? We'll call it T for time, and we'll call it S for snacks. So we have to look at it. Does the amount of time depend on how many snacks I bring, or does the number of snacks depend on how long I hike? So in this case, the number of snacks depends on the time of your hiking. So the number of snacks is our dependent variable, so we'll call this D for dependent, and the time is our independent variable. Amelia is making mushroom tarts for a party, which, by the way, sound really gross. The number of tarts she can make will be determined by how many mushrooms are in the fridge. So again, we need to identify our two missing pieces or our two unknowns. So it would be the number, excuse me, the number of mushrooms. I'm going to call them the number of M for mushrooms and T for tarts. So you have to say to yourself, does the number of mushrooms I make depend on how many tarts I have, or the number of tarts I can make depends on the number of mushrooms I have? So what we find out is that the number of mushrooms is our independent variable, and the number of tarts is our dependent variable, because the number of tarts I can make depends on how many mushrooms I have. Taylor's dad is building a case for his trophies. The number of trophies will determine how many shelves the case will have. So we have two unknowns here. We have the shelves, so we'll call them S for shelves and T for trophies. So again, we say to ourselves, do the number of shelves I need depend on how many trophies I have, or does the number of trophies I have depend on how many shelves I need? So we have to take a look, or shelves I have, excuse me. We need to take a look at these two scenarios, and we see that our independent variable is the number of trophies, because I can have 1, 2, 3, 4, 5 trophies. Then that will determine how many shelves I need, so that becomes our dependent variable. Okay, it says the table shows the relationship between the pounds of dough prepared and the number of hours worked, and we're calling the pounds of dough prepared P and the number of hours worked H. So we're going to write an equation to represent this relationship, and then we're going to predict how many pounds of dough will be prepared after 24 hours. So in this table, I know for sure that the independent variable is how many hours, and my dependent variable is how many pounds I'm going to prepare. Okay, so what we're going to do here now is we need to write a relationship that says P equals, because how many pounds are going to be prepared depends on what's happening with our independent variable H, the number of hours I work. So I'm going to look to the relationship of what's happening with H to get to P. So I see here, well, I can do one of two things. I can add 18, or I can multiply by 3. So let's try multiply by 3. 9 times 3 makes 27. Then I got to check again. 10 times 3 makes 30. I'm going to check one more time. And 11 times 3 makes 33. So we know that the number of pounds prepared is 3 times the hours, and we would write 3H. So now to make a prediction of how many pounds of dough can be prepared after 24 hours, I just go ahead and substitute it in. So I have P equals 3 times 24. And when I do the math, I find out that P, or the number of pounds prepared, would be 72 pounds after 24 hours. The table shows the relationship between the minutes Vanessa spends walking and the number of laps around the track she completes. Write an equation to represent this, and how many laps will she have completed after 72 minutes. So her C stands for the number of laps around the track, which is our independent variable, and our minutes is our dependent variable. So in this situation, remember this depends on this. So it's going to be M equals. And now we have to decide what's happening here that's going to result in this. So if I look here, I have two ways of going from 3 to 18. One is to add 15. So if I do 3 plus 15, I get 18. Good. 5 plus 15 doesn't make 30. Not good. So the other way is to do times 6. So let's take a look. 3 times 6 makes 18. 5 times 6 makes 30. 6 times 6 makes 36, and 8 times 6 makes 48. So we're taking our laps and multiplying by 6 to get to the minutes. So the next question says, how many laps will she have completed after 72 minutes? So I have to plug that in. This is the next question on your study guide. So it becomes 72 equals, because I'm plugging in for minutes, 6C. And then this becomes a division equation, so I divide by 6 on both sides to get to C equals 12 laps. In this problem, it says the following table represents the equation y equals x minus 4. And we're going to fill in the missing values. So as you can see, I have my x and my y, and remembering that my x is my independent variable and my y is my dependent variable. So whatever happens to y, or however I get y, depends on what's happening to x. And in this case, it's x minus 4. So I would substitute in 5 minus 4, because that's my x value, is 1. So y results in 1. Here I do 7 minus 4, which results in 3. But now I'm given my y value, so I have to work it backwards. So it's like solving an equation. I would have to add 4 to both sides in order to do that. So I'm going to do 24 plus 4 makes 28. And I can check to see if it works. Does 28 minus 4 make 24? Yes. So I would have to add 4 on this side, which makes 34. And I can quickly check it to see that 34 minus 4 makes 30. Ella's birthday party costs $3 for every guest she invites. Write an equation that shows the relationship between the number of guests and the cost, and then complete the table. So when we look at this, if it costs $3 for every guest she invites, the cost depends on the amount of guests. So we have our independent and our dependent variables set up here. So this is our independent, this is our dependent. And so now I have to go here and I have to understand what $3 for every guest costs. So if I have 5 guests and each of those guests is going to cost, or each of those guests is going to cost me $3, I'm going to have to multiply by 3 in order to get my cost. And that comes from right here, $3 for every guest. So then I would have to do times 3 here, and it would cost me $30. And I'd have to do times 3 here, which would cost me $45. So now I need to write my equation. Since this is my dependent variable, it's going to be C equals. And what did I do to each of them? I multiplied the number of guests I had by 3. So C equals 3 times G. In this problem, it says Harry rides his bike at an average rate of 15 miles per hour. Write an equation that shows the relationship between the distance d that Harry rides and the number of hours that he rides. Complete the table to represent the scenario, then graph the function, and be sure to label your table and graph. So we're going to be doing all three scenarios here, and if you remember from class, we talked about that. We can take the table, make it into an equation, then we can graph the equation of the line, and that's what it means by then graph the function, because we talked about it being a function table. So in this scenario, we have to determine which is our dependent variable and which is our independent variable. And in this case, our dependent variable is going to depend on the time that we ride. So the dependent variable is going to be the distance. So I'm going to write D for distance here. Depends upon the time that we ride, and I think we call that H for hours. And when we talk about 15 miles per hour, we're talking about taking how many hours we have and multiplying it by 15. So D is going to be 15 times H. So we can substitute in any amount that we want. So the easiest things to do would be to do 1, 2, and 3. We'll just do 3 points this time. So if I go 1 hour, how far do I travel? 1 times 15 is 15. So I would travel a distance of 15 miles in 1 hour. And that makes sense, 15 miles per hour. So I would put 2 in there. 2 times 15 makes 30. So I would go 30 miles in 2 hours. And I substitute in 3. 3 times 15 is 45. So 45 miles in 3 hours. Now remember, even though these are called H and D for hours and distance, this is still my X and this is still my Y. So this is my X on my coordinate plane, and this is going to be my Y. And remember, this is just going to be quadrant 1 because it's going to be positive because we're dealing with time. So for X's, I have to label them 1, 2, and 3. So I'll put a, how about we do this? This will be like our line, and we'll leave some labeling lines here. We'll do this, and we'll do this. Oops, sorry. Okay, so we'll call this 1 hour, and we're going to call this 2 hours, and we're going to call this 3 hours. And remember, this is still 0, 0, so we'll put the 0 there. Then looking at my distance, it goes up by 15, so I'm going to call this 15. I'm going to call this 30, and we'll call this 45. So I go ahead and graph the ordered pairs. Remember, this is 1 and 15, so I do 1 hour means 15 miles. And we can call this hours. We should probably label off to the side here. This stands for H for hours. And then this one standard Y for our distance. Okay, so we put a dot right here for 1 and 15. I go back to my graph 2 and 50. Excuse me, 2 and 30. I can't even read my own writing. 2 and 30. And 3 and 45. And I know that I did this right because remember, it's 0, 0 would be, and then we haven't even started yet. And here's my semi-straight line. So again, the graph matches the equation, which matches the table. Okay, in this situation, it says the town parking meter charges 50 cents for every hour. So in your minds, you should be thinking, okay, 1 hour is 50 cents, 2 hours is $1, 3 hours. So you see that we're having a multiplication problem going on here. So it says write an equation that shows the relationship between the cost of the parking, C, and the number of hours paid for, H. Complete the table to represent the scenario. Then graph the function and be sure to label your table and graph. So again, we have to identify the independent and the dependent variables. So I have to say to myself, does the cost depend on the hours or does the hours depend on the cost? And you just kind of answered your question there that the cost, C, depends on how many hours I park. And so it was 50 cents per hour, so we have C equals, and I'm just going to use 0.5 because that's the same as 50 cents. No sense in putting in the 0, it just might confuse me. 0.58H, which means to multiply the hours times the amount to get to the cost. So again, we're going to put in 1, 2, and 3, and if you would like to, you can try out a 4th one. And so we're going to do the math here now. If I substitute in 1, if I go 1 hour, it costs me 50 cents. And again, we got that directly from the problem. It said 50 cents for every hour. So if I do 2 hours, that means I've doubled this, in case you're not good with your decimals. So it cost me $1. Since I've got 3 hours, I can add the 1 and the 2 together, 3, so this becomes $1.50. So we're actually using this as a ratio table because it is multiplication. And then if I did 4 hours, I'm doubling the 2 to get to 4, I double the 1 to get to $2. And so then I need to graph it. So again, I come over here, and this is going to be my x-axis. And I'm going to label it X, but I'm also going to label it with an H because the hours is going to go along the x-axis. And then along my y-axis, we'll label this Y, and we're going to call this the cost. So I'll put C for cost. So I know that my X's and my Y's. And again, this is 0, 0. It doesn't cost me anything to park if I haven't parked there. So that's for 0, 0. So now along my hours, I have 1, 2, 3, and 4. So we'll do 1, 2, 3, and 4. And then looking on my y-axis, it goes up by 0.5, so we'll do 0.5. And again, I'm leaving off the zeros just so it doesn't get crazy. 1.5 and 2. And then I graph my ordered pairs. I have 1 and 0.5, so 1 and 0.5. Remember, I go right first, then up. I go to 2, and it will cost me $1. I go to 3, it cost me $1.50. 3 hours cost me $1.50. And 4 hours would cost me $2. And then I connect my points all the way up to show that I made a straight line. Each bag contains 20 lollipops. Write an equation that shows the relationship between the number of bags, B, and the number of lollipops, N. Complete the table to represent the scenario, then graph the function to be sure to label your table. So again, we need to identify our independent, our dependent variables from here, and then of course our equations so we can complete our table. So we have two unknowns. We have the bags of lollipops, and we have the number of lollipops. So does the bag depend on the number of lollipops, or does the number of lollipops depend on the bags? And so what you have to say is that the number of lollipops depends on how many bags you have. So N becomes our independent variable. The number of lollipops, depends on how many bags you have, and B for bags. So it says that we have 20 lollipops per bag. So in one bag I have 20, in 2 bags I have 40, in 3 bags I have 60. So I can see that the number of bags is going to be equal to 20, the amount of lollipops, times how many ever bags that I have, so 20B. Okay, so now I can substitute in, and I start out with really very easy amounts, 1, 2, and 3. You can do whatever you want. And I substitute. 1 times 20 is 20. So, and again, it goes back to our scenario. Each bag contains 20 lollipops. So one bag has to contain 20. I can see that right there. You could always fill this in first, then see how to come up with the equation if you needed to. 2 bags is 40. And 3 bags is 60. So I have to come over and graph my function. So again, this is going to be our x-axis. This is our y-axis. Our x-axis stands for the number of bags. And then our y-axis is going to start for N for the number of lollipops in the bag. So again, this is 0, 0. And we're going to label it 1, 2, and 3. And then up this axis, since these are going up by 20s, we'll label this 20, 40, and 60. And so I graph my ordered pairs. 1 and 20 go together. So I go right 1 up to 20. 2 and 40 go together. Right 2 up to 40. And right 3 up to 60. And remember, if I don't have any bags, I don't have any lollipops. So that's 0, 0. And we connect the line. That should be a nice straight line. That doesn't look so straight, but it's supposed to be. Okay, so in this scenario, it says, in the state of Illinois, you can get a driver's license at 16. Write and graph an inequality to represent this situation. So what I always like to do when we start off thinking about inequalities, remember, inequalities have more than one answer. So who can get a driver's license? 17-year-olds can, 18, 19, and you can see my numbers are getting larger than 16. So I have to ask myself, can 16-year-olds get a driver's license? They can, and I'm going to go ahead and circle that because it is included. So we're going to go ahead and color that in. So to write my scenario, I'm going to put, I'm going to use the letter A for age of anybody that can get a driver's license. These are all my answers have to be greater than and equal to 16. Okay, so then I need to graph it. So I draw my number line here. And on my number line, I'm going to put 0. I'm going to use negative 16 since that's my reference number. And I'm going to use positive 16. So from here, I know that since 16 is included, I have to include a closed circle. And all my answers are greater than 16. Greater than 16 goes to the right. So it's a closed dot going to the right at 16. This problem is asking you to explain the change in y as x increases by 2. So what I've done already is I've put a table on my sheet, because remember, if I have the graph, I can write the table, I can write the equation. You have a couple ways that you can say this. So I put the table on here. I'm going to label this x and this y, and I'm going to go with my points that are on my line to see if I can see what's happening. So remember, proper math etiquette is we go all the way to the left. We see that this one is at 0 and it goes down 2, so I'm at 0 for x and I'm at -2. And then I come to my next point here, which is at right 2 up nothing, so it's 2, 0. And I come over here, I go right to the 4 up 2, so this is 4, 2. So now I can take a look at my table to kind of better understand what's happening. So it says explain the change in y as x increases by 2. So it goes up by 2, up by 2. What's happening here? Y also goes up by 2. Okay, so that's one thing that you can say. Y also goes up by 2. Or you can say, well, how do I write the equation for this line? And remember, it's always y equals, because y depends on what happens to x. So how do I go from 0 down to 2? I have to subtract 2. So let's see if it works. 0 minus 2 is -2. 2 minus 2 is 0. 4 minus 2. So I could write x minus 2. I can also write the equation for the line. Okay, so we need to explain the change in y as x increases by 1. So again, I put my table into my problem here because that helps me see it a little better. We label this x and this y, and then proper math etiquette says we move all the way to the left of the line. The first order pair that I see is -1 and 1, and my second order pair is 0, 0. And my last order pair is 1, -1. So as x increases by 1, you can see it's getting larger than 1, getting greater by 1. What happens to x? X is decreasing by 1. That would be one way to explain it. Otherwise, we can write the equation y equals, and we take a look at whatever is happening to x. Y depends on whatever happens to x. So if x is a -1, that means y is a +1. If x is 0, y is 0. If x is a +1, then y is a -1. So what's happening is we're doing the opposite of x. And because 0 doesn't have an opposite, it still remains 0. So what is the opposite of -1? +1. What's the opposite of 1? -1, and that's how you would come up with the equation for this line. Mark is twice as old as Emily, or excuse me, Maria is twice as old as Emily. Maria is 12. How old is Emily? Prove that your answer is correct. When you see prove that your answer is correct, that means that you need to write an equation and solve the equation to show Emily's age. So remember, with these types of problems, we always start with what we know. We know Maria is 12, and since she's twice as old as Emily, that means Maria is older. So I would have to divide by 2, because she's twice as old, in order to find Emily's age. So we start with the solution first. And then remember, we draw our line, and we show the other side. So that would be a divide by 2. In order for me to divide by 2, I'd have to multiply by 2 for my equation. So 2e equals 12 is your equation. These cancel out, so e equals 6. And we substitute back in. Does 2 times 6 equal 12? Yes, 12 equals 12. So my solution is correct. Emily has to be 6 years old. That is how you would prove that your answer is correct. Jackie has 5 more pieces of candy than Jan. If Jan has 12 pieces of candy, how many does Jackie have? Well, in this case, in order to prove our answer is correct, so we have to write our equation and solve it. Jackie has 5 more pieces than Jan. So Jackie actually has more than Jan. So we would do 12 plus 5 to show Jackie's amount, correct? So then we know that Jan had 12. So again, we set up our equation. So if I added 5 to get to my solution, that means I added 5 on the other side of the equal sign. With addition of 5, which means I had to subtract 5. So we'd have j minus 5 equals 12 as our equation. It's a really weird looking j. And then in order to solve, we know that minus 5 plus 5 cancels out. So J is going to be equal to 17 pieces. So Jackie has 17 pieces and Jan has 12. And it makes sense because Jackie has 5 more than Jan. So we substitute back in. Does 17 minus 5 equal 12? Yes, 12 equals 12. We know that we did it right. We also proved it with our check. Alex and his 2 friends went to dinner. Each person paid $12.12. How much was the total bill? So we know the total bill has to be greater than this. That's one thing you have to think about. We also have to think about it's Alex and his 2 friends, which makes 3 people. So if each person paid this, then in order to solve it, I'd have to do 1210 times 3. So then I put my equal sign and my line down the middle to show both sides. So if I'm multiplying by 3 on one side, that means I had to multiply by 3 on the other, which means I have to actually divide by 3 for my equation. So my equation is x divided by 3 equals $12.10. So then off to the side, I'm going to do $12.10. That's a dot there. And times 3. And I multiply like normal. So that's 0, that's 3, that's 6, that's 3. So that's a 0 on the end. And I have 2 decimal places in my problem, which means I need 2 decimal places in my answer. So x equals $36.30, which makes sense that the total bill would be that. So then I would come over here to do my check. So I do 36.30 divided by 12, or excuse me, divided by 3 equal 1210. And I could do a quick math check by dividing it out. And yes, 1210 equals 1210. So I proved that my answer was correct. George had 3 less baseball cards after the trade. He now has 15. How many baseball cards did he have to start with? So we know that he now has 15, so he has to equal 15, and he had 3 less prior to the trade. So we have to add in order to find out how many he started with. So again, I draw my line to show my opposite sides of the equal sign. Since I added 3 to this side, means I had to add 3 to this side. In order to add 3 to both sides, it means I had to have a subtraction equation. So G minus 3 has to equal 15. So I go ahead and do my math. That cancels out, which leaves me with G on this side. G equals 18, which means that George started with 18 cards. And we check. 18 minus 3 equal 15. And we do the math. 18, 17, 16, 15. 15 equals 15, and I check and I've proved that my answer is correct.